going to talk to you about the group-based policy model and OpenStack. He's from Cisco. We're very glad to have him, so give him a warm round of applause. And
welcome all. First, one promise. I only have one slide with a product, and that's because I was too lazy to change it. So no product pitches, just technology. I always have to tell that when I'm not pitching products, so warnings, now I can begin. I'm Bart Jan Menkveld, system engineer at Cisco, and I usually work where open source technology touches our products. When I'm not working, they allow to do that. I do American Campo, yellow belt, so the risk of hitting you when I not want to hit you is about as large as the risk of hitting you when I want to. Ride motorcycles, and I like to solder stuff with LEDs and Arduinos, etc. So that's about me. Before we start, a bit of background. Who knows OpenStack? Good, good. Then I'm going to skip quite fast over this. This is the mission statement of OpenStack. And basically it is to create a cloud which is massively scalable and easy to deploy. Which of one of those is actually working right now? None of them. Okay, true. I'll award you a book for that.
Awesome, thanks man.
But in the end, the massively scalable tends to be quite there. I mean, NASA, Rackspace are doing nice things. We also are, but that's a different story. But the easy deploy is something else. But indeed, both of them not there could be the right answer. So, pets versus cattle. Who can explain to me what those two have in common and what do they bring to IT? And please, don't be shy, come on. He already has a book.
Yeah, I'm not going for a second book.
No answers, shy audience. Okay, walk to there.
You give your pets a name. You name your pets and care for them. Cattle doesn't matter when they get sick. You shot them and get a new one.
Perfect. I'll throw you a book later. I'm not going to throw it from front. That's too dangerous. But indeed, that's almost what I wrote down. Your pets, you care for them. If they are sick, you heal them. And your cattle, you just shoot them down. Good. One more thing. Imperative versus declarative. You shut up. You shut up. Anybody else who wants to explain? Again, shy audience. But I need a volunteer. And if nobody gets here, I'll appoint a volunteer. You look very volunteer to me. No? Come on, help me. Okay. Please, welcome. Can you come over?
I can come over.
You both get a book, but I need two. That's good. Come over, no problem. So first, I'm going to do imperative. Hold this, please. I am a SDN controller or whatever kind of imperative device you can imagine. Here's a switch. Ho ho. I didn't tell you I'm imperative. I didn't tell you anything. And I'm going to explain to you how you can drink. Because me as SDN controller, I have a mission to get people hydrated. So I tell you, I can see a bit of state, I can see a bottle, and I can see an opening where water could enter. So I'm going to tell you, please move your hand and move it like this, 180 degrees. Okay, now it's good. Move your other hand up and left, right down, yes, grip, grip. You see, it takes me a lot of effort to actually, well, get him to drink, because I gave a lot of comments, and the only thing he has accomplished is getting his hand on the bottle, and, well, I don't even gonna try starting to make you drink. And if I change my implementation, for example, I remove the bottle and give you a can, that's difficult, because I have to rethink as controller about how to get him to drink. Now we're going to try a declarative. Would you like Coke or you have first choice? Want a Coke or a Spa?
I'll get the Spa.
Okay, we're going to do it declarative. I declare my desired state. I don't want you to get thirsty. If you get thirsty, drink. And I'm done. I don't care how he does it. I have expressed my state. If you're thirsty, make it go away. But it's the same basically we do in IT. If I have a puppet script, a declarative way of controlling my systems, I just say, ensure present, and the system makes sure it's present. If I write a shell script, I have to check, I have to download things, I have to install them. So that's a big difference in how we look at things. I find it easier as a controller to be declarative. You take care how you drink, I don't care, just do it. So, difference between the two. This makes some sense probably later, this talk. So, why would we need a group? You're finished, by the way, so take your drink with you if you want. You can leave it here if you don't.
Declarative, right?
Yes, if you want. But it's my intent to let you take it with you. So why do we need something else in OpenStack? We have a cloud, we have networking right now, we have Neutron. Who is fond of Neutron? See? But in the end, there has been a lot of evolution in OpenStack. I mean, we have to give it some credit. It started as a project, well, basically as two projects, Nova and Swift, brought together a couple of years ago, and it's grown. It's grown fast, and it's fast, and more, and more. And in the end, we have, slides from last year, probably there are a zillion more right now. We have a lot of different projects which are all OpenStack. And it's not all bad. They brought some pretty good things. I mean, it is finally an open source API used to control your data center. I mean, that's something. It's common resource abstraction. I mean, if I use a Cisco switch or a Juniper switch, whatever, which has a Neutron driver, I can create a VLAN without caring how it works. As long as I have a compatible API, a compatible plugin, it works. So yeah, that gives me some automation, and it helps a bit in operation. But for every good, there must be bad. Otherwise, why should I put it here? And the most important things, I have to, well, leak implementation details. If I configure a subnet, and I create basically a policy zone, and I have to think about IP addresses. I have to think, is this IPv4, IPv6, is this a firewall? A lot of implementation details are leaked up the stack where I don't really want them. And for me, it's really an imperative way of configuring the network piece of OpenStack. I have to tell it step by step by step what it has to do, and I'm not able to present an end state. I'm only able to present step by step by step what you have to do. And in networking itself, we also have quite a few challenges. Because we started with applications, we put them in subnets, very easy. Well, some things are tied to that subnet. For example, routing and layer 2 separation. That's quite logical to put that to a subnet. But load balancing, security, whatever kind of service we can think of, we all tied that to a subnet. So now that thing which was basically built to be an address is now part of your policy. It's part of your service. It's part of your, well, basically your world as packet, your world as application, and it's no longer just an address. So we need something else. And also quite important, languages. I mean, we are here at a very development-oriented crowd, so that's good, but they talk about different things. The people, like Job mentioned, who understand both are very rare. And we need a lot of times to translate between networking and application people, we need a human translator. And everywhere where the human translator comes in, things go wrong. Because even in Dutch, if you both talk the same language, you can really misunderstand each other. And that's why easy subjects. So if we talk about complex things, like IT, it's still complex, a lot of things tend to go wrong. So we try to bridge that, make that bridge go away, and merge those two worlds with a new model, what we call the group-based policy module. So this is the only slide with products. You can ignore the lower part if you want. I was too lazy to create a new one. We try to solve that as networking industry, because we came from a traditional network model where we configure box by box by box, and well, that doesn't really scale. If I have a lot of boxes and I have to configure them manually, doesn't gonna fly. So enter software-defined networking, buzzword of the day. Well, I was very glad to hear a talk about SDN. First time I think ever, where somebody was not saying, oh, SDN, oh, OpenFlow. Yeah. I mean, who has a valid use case for OpenFlow for me and a real valid? Yeah?
I use it.
Okay, good.
Quite extensive.
Yes, I know you are, and you are the one of the few I actually heard about a good use case. So, very good. Oh, you already have a book.
We'll have beers.
Absolutely, and there are some use cases, but it's not solving everything. And a lot of times, it's not a real problem. Just like Job said, his real problem was configuration consistency. It was abstraction of somebody clicking to the physical device. And I see that more often. But I'm very glad to hear your stories, absolutely. So what we thought, well, we have to move to a more application-centric way. Of course, that's the marketing terms. The technical terms come back to the OpenStack world. And what do? I'll take here a traditional, easy treater application. I'm not going to, in this crowd, I should probably have built some microservices, large segmented thing, but I have to understand it, and I'm a networking guy. So I took something I could understand as a networking guy, and that's a treater application. So what is that application? It consists of a couple of things. First thing is groups of services. Commonly, services with a common policy. I'm not saying subnets, not IP addresses, it's just groups of virtual machines, physical machines, couldn't care less, services. They provide applications. Connected to those are contracts. And here it starts to get a bit abstract for most people. A contract is what does this group consume or provide to other groups. So I have here a web farm, and what does a web farm provide? Access to port 80 and port 443 probably. HTTP, HTTPS. So my web farm, my web group has a contract where it says, I am happy to provide HTTP to whatever. My application server has a different contract. He has a contract stating, I'm happy to provide application services to whatever needs it, but only in my internal network, for example. Databases, well, comparable. You don't want databases accessed from the world, but also they have a contract stating what they can provide. In the other way, you consume services. As a web group, I say, I have here a service called application, and I'm willing to consume that. So that's a one-time definition. Your definition, you're outside, it consumes web. Your web consumes application. Your application consumes databases, and to be able to consume it, somebody has to provide it. Is that differentiation clear? What a contract is and how it's used? And this is before we talk about subnets and IP addresses. Being silent, I think that's a yes in this crowd. And in the end, we also have one more thing, that's our service change. Because a lot of time, we don't want to connect things directly to another group. We want some kind of policy device in between. It can be a firewall, it can be a load balancer, an IPS. Basically, I don't really care. As an application designer, which I'm doing here, I'm designing a stack, I don't want to care about how that firewall is implemented. I don't want to configure that manually, I just want to say this has to be firewalled. That's up to a security group to decide what the best firewall could be. But not to me, I don't want to be bothered. So this combination, service change, where we map connectivity to external or internal security devices, contracts, so stating what kind of services I'm able to provide or to consume, and groups within the same policy, those combined form what we call an application network profile. This is how Cisco calls it in our products. We have chosen, very important, to not keep this model for ourselves. We thought this is a good thing. We said, well, this should belong in the open source world. Because in the end, if we think of a model which is great, and we are the only one implementing it, none of our customers is going to implement it. I mean, the world that companies like Cisco, if it even ever existed, I mean, I'm not that old, but can dictate what customers want to use, come on, that's not an utopia, it's more a dystopia, it's not good. We are, I think, the only way to make something successful is to build the best implementation and let the market decide who does that. So that's why we open sourced this model, pushed it to OpenStack, and it's now being implemented by other vendors also. Extreme Networks, Nuage, not really our friends. But they have took this model because they said it's a good model, giving the customers the choice, if they like the model we thought of, to implement it and to use it. So to not lock people in, but giving them the choice for the best implementation. So now we move to OpenStack. How am I on time, by the way? Okay, then I have time for a quick drink. So far, no questions. It's quite silent here. Or all questions for beer o'clock. That's also good. So, we have the OpenStack high-level architecture. Very high level. What do we have? We have networking, compute, and storage. Right now, I'm only going to talk about the network. On top of that, there are APIs and implementations. The big boxes are the APIs, and the smaller boxes are implementation. We have some for compute. You can use different hypervisors. For storage, you could use different vendors, etc. Open abstraction. And in the right side for you, you have the GUI or the CLI, anything which is able to talk to that API. Very basic OpenStack architecture. What group-based policy is, it's sitting between your automation layer, between your, well, access portal, and those abstractions. At this moment, only for network. Compute and storage is on the roadmap, probably somewhere in the head of people much smarter than me, but at this moment, it's a networking thing. So we go back to the old 3-tier app, and I added some management, use database or monitoring, etc. So how would we do this before we had a group-based policy? Who wants to try? Well, we have to think about subnets. We have to think about which routers they are, what's my external gateway. And if I change something, if I add a subnet to a group, because my subnet is full or whatever, I have to rethink about it. I have to reconfigure routers, I have to re-orchestrate basically my policy. So that takes a lot of work. And it exposes details about, well, like I said, IP addresses, etc. Exposes them to your application. And it adds a concern on a layer I don't want it. So, group-based policy. This is the terminology in OpenStack, a bit different than we use, so I'll stick to those. We have groups. Those groups have policy rule sets, what we call contracts. Call it here, with policy rules, classifiers, server chains, and actions. Easy. My classifier is basically, well, if I call it an ACL, probably some people are going to hit me, but it's an ACL. It says what kind of traffic do I want this policy to be for? And then we have an action. Action could be simple like drop or allow, and it could be for sending it to a service chain. So for example, in my previous picture, my monitoring traffic, if I want to do a simple ping to a machine, why should I firewall that? I mean, a simple ICMP, I don't really care. If I get a reply, I'm happy. So in my classifier ICMP, action forward. No need to send it to a service chain. But for my user authentication, I might want to put it to an IPS. Same groups, same IP subnets, could be not. Classifier, user authentication. The action can be, put it to a service chain where an IPS is. So traffic from two hosts with the same IP addresses, using different protocols, can be sent to different service chain for different usage, for different handling, based on what that application dictates. So, if we look again at our 3-tier application, a bit more in-depth, we have web group, app groups, and we have different monitoring groups. The web group provides to the external group the web service. The external group consumes that service web. In that group, in its service chain, it's said you have to pass firewall and load balancer. Otherwise, yeah, it's not valid contract. The web group consumes again the application. The application provides the services to the application group. And in the other here is the same. All these groups upside, they consume existing shared profiles for existing shared services. So, is that clear what we're doing here and how this is different than configuring an ACL? I see a couple of nods. It was good. Because I'll be honest, the first time I saw a presentation about this, I had also, okay, let me look again. That's quite common for networking people to have that. So don't be afraid. Is it real life yet, or is it just vision? Well, it's not yet in the mainline OpenStack. We probably, it will be Icehouse when it's just general part. But you can do it right now. So command line, we created a new command line, GPP, yay. And then you can create, well, entries in your OpenStack environment. And also you can do it via Horizon, new tab, policy, where you can create your service chain, your application profiles, etc. And of course, we have also constructs for heat for your orchestration if you want that. More information is on these sites. Probably the slides are going to be shared? Yeah. Okay, then I'm not going to read out. And if you want to try it, it's in DevStack, so you can install it, you can play around on your laptop, and well, try it and see if it works for you and how it can make your life easier. Good. This was basically what I had to say for now. I have to give some books away. I have more, so if anybody wants to read, I have books. Any questions?
Okay. So I have a question. I see the group-based. The group-based policy model, and I wonder, is it like a name for a certain configuration for that you can apply? I mean, isn't it like a template sort of thing? Or I mean, group-based. To me, the name is quite confusing.
Yeah, I mean, we're good at some things and not at thinking about names. But no, an application network profile, you can see that as a template. And the group-based policy, it's a model, it's an abstraction layer. I think that's the best way to look at the model. And a single application network profile is a template. So I create one for the used and abused 3-tier app. So that's a template how that application should look. And I put services in that template. Any more?
I understand how it works basically, but instead of ACLs with IP addresses, you like put a description sort of, like a group, and then inside that group you specify which servers it's based on. But how does that work? Is it like MAC address based or IP address based, or?
Let me take the mic so everybody can hear it. So the question is, how do you form a group? And basically that's up to the implementation. You can do IP addresses, that's very easy and that's very understandable for network people. But for example, you could also use a name of a VM or a MAC address or a combination of those. So it's not restricted. You could have one single /16 subnet and put everything in there and let your implementation decide how it handles the separation. So it is up to implementation how you separate that. If I look at our own implementation, at this moment we do MAC addresses, we do VLANs, we do subnets, so the basic network constructs. And in our roadmap we have the VLAN names, port descriptions, etc. So yeah, it's pick what you want and pick what your implementation provides.
Okay. What about physical ports?
Yeah, that's also an option, just to put them in. Yeah, absolutely.
First of all, thank you for telling us about this novel concept. I never heard of it, and I'm sure I'll find inspiration in it. So thank you. Second question, to be pedantic, does it support IPv6?
It's an exception model. So yes, because we don't really care about what's in there. I could have a policy group which has IPv4 and v6. If every implementation supports it, that's a different question. And I believe at this moment our implementation does, by the way, but that's an implementation question. The policy model itself doesn't concern with IP addresses, be it 4 or 6.
So the thing that concerns me a bit is I live in multiple worlds. And I'm actually one of the persons trying to push towards the concept of that policy should be married to an application you're deploying and should not be married to infrastructure. So how do you view that with this policy model?
Well, we tie the policy to an application. So application network profile is your representation of an application. And you choose where you want to enforce it. It is totally free to make an implementation of the model which uses only, for example, let's keep it in the IP world, IP tables on hosts. That could be totally possible. I don't know if it's a good idea, but it's possible. So it actually brings you an abstraction layer. And you can choose, do I want part of this abstraction to be handled by my physical infrastructure? Or do I not want that? Or you could, for example, Open Daylight controller, SDN controller, is working with this. So you could push this to your Open Daylight controller. I don't know which overflow controller you're using. And have that one enforce that policy. And that policy is tied to your application, and you choose where it's best to enforce it. It could be in an overlay, it could be in a physical network, could be in both.
It's more the concern of that you want to marry your application and your policy in an intrinsic way. And now they're very loosely coupled in this model because I can choose not to enforce that policy.
Yeah, true. Yeah, that's true. And that's, well, yeah, it's a difficult... I believe in, for example, a Jericho model where infrastructure doesn't do anything and your application is secure, but self-contained and secure, but I think that's also utopia. And we still need firewalls. We still need intrusion prevention systems. And they still bring value to, well, basically our customers here. So, and I think in the ideal world, they wouldn't be necessary. Your application would be self-contained and secure in itself. But at this point in time and for the foreseeable future, I think there's value in infrastructure to provide part of that service. And that's where this is a great abstraction layer, according to me. So, stand up, otherwise I'm blinded. Last questions? Good. Well, everybody who wants a book or who I did bother with being volunteer or questions, please get one. I don't want to pick them up, and they're quite interesting, actually. So, thanks for your time and attention.